There's a very important theorem in calculus called the mean value theorem. And before I talk about the mean value theorem, I want to talk about kind of where it comes from. So first thing I want to do is remind you of the algebraic formula for the slope from 2 points. So say, for example, x1, y1 and x2, y2. We of course know then that m equals y2 minus y1 over x2 minus x1. Well, what if instead of given 2 points, x1, x2, x1, y1, and x2, y2, what if instead we're told that we had a function on some closed interval from a to b and we wanted to find the slope of that? Well, if I have a closed interval, I should be able to plug each of my endpoints in to find their y values, and then I can use those to once again use my algebraic slope formula. So if I plugged my first endpoint a into my function, when I plug a into my function, I get f of a. If I then plug my second endpoint b into my function, I get b comma f of b. So now instead of calling it x1, y1, and x2, y2, notice now I have a and f of a and b and f of b. Notice I could still find my slope formula from this using my y2 minus y1 over x2 minus x1 formula. Instead it would look like f of b minus f of a all over b minus a. Well, that's exactly what the mean value theorem says. It says as long as we have a function that's continuous on a closed interval, call it ab, and as long as it's differentiable on at least the open interval, it doesn't necessarily have to be differentiable at the endpoints, then there is some number, some x value in your interval, say we call that x value c, where the derivative is equal to your slope formula, f of b minus f of a over b minus a, right here. Basically what that is telling us is that at some point, even if only for a second or for a 0.00001 amount of time, but at some point our instantaneous rate of change is going to be equal to our average rate of change. This formula that we've always known as the slope formula, we're going to start referring to it now as our average rate of change formula versus our instantaneous rate of change formula. So here's kind of a picture of that could represent this. So if I look at this green graph here, I see that I have 2 endpoints and that I can use those endpoints to calculate my slope. Well, there's going to be some value that's going to have that exact same slope. And again, we're calling that point arbitrarily c. So I think I have 2 examples. So let's look at these 2 examples. If I have the function f minus 4 over x, I want to find any values c between 1 and 4 so that my derivative is equal to my average slope. So let's find my slope. So I can find my slope by saying, hey, I'm going to plug 1 into my function. And if I plug 1 into my function, I get 5 minus 4 over 1. Well, that's 1, 4. And I'm going to plug my other endpoint 4 into my function. And that gives me 5 minus 4 over 4, 5 minus 1, so I have the point 4, 4. So I want to figure out when my derivative is equal to 4 minus 4 over 4 minus 1. No, this isn't supposed to be 4. This was supposed to be 1. Because when I plugged 4 in, no, when I plugged 1 in, I got 5 minus 4 over 1. So that should have been 1, 1. I apologize. So I'm actually going to have 4 minus 1 over 4 minus 1, which gives me 3 over 3, which gives me a slope of 1. So I want to figure out when does my derivative equal 1. Well, I better find my derivative. So I had the function 5 minus 4x to the negative 1. When I find my derivative of my function, I end up with positive 4x to the negative 2. So I'm trying to figure out, now that I have my derivative and now that I have my average rate or my average slope, I'm trying to figure out when does 4 over x squared equal 1. Well, if I multiply both sides by x squared, I'll get when does 4 equal x squared. Well, if I take the plus or minus square root of both sides, I get x equals plus or minus 2. My interval only goes from 1 to 4, so I will not list both of them. I'm not going to list the negative value, and I get x equals 2. So when x is 2 or when c is 2, call it whatever letter you want, my instantaneous rate of change is going to be equal to my average rate of change or my average slope. Let's look at one more example. So now I have a new function 1 over x. I'm on the interval again from 1 to 4. I want to find the x value where the instantaneous rate of change is equal to the average rate of change. Well, that just means the mean value theorem. So I need to find instantaneous rate and average rate. So first thing I can do is I can find my average rate by saying I need 2 points. So I'll plug 1 into my function, and when I plug 1 in, I get 1 over 1 is 1. And then I'll plug 4 into my function, and when I plug 4 into my function, I get 1 over 4. So I can find my average rate of change, or my slope. I'm going to call it m average. I get y2 minus y1, so I get 1/4. Let's do 1 minus 1/4. I'd rather not have negatives. So I get 1 minus 1/4 all over, I guess it doesn't matter, I'm going to get negatives anyway, 1 minus 4. So that gives me 3/4 over negative 3. Positive 3/4 over negative 3. So I get 3 over 4. Dividing by negative 3 is the same thing as multiplying by negative 1/3. And my 3's cancel and I get negative 1/4. So my average rate of change is negative 1/4. So I want to find out, when does my derivative equal that? Well, if f of x equals 1 over x, or x to the negative 1, then f prime of x will equal negative x to the negative 2. So I need to find out, when does negative, let's move that negative 2 to the bottom, when does negative 1 over x squared equal negative 1/4? Well, I'm going to go ahead and cross multiply. So 4 times negative 1 is negative 4. X squared times negative 1 is negative x squared. Multiply both sides by a negative 1. I get, when does 4 equal x squared? So again, I get x equals plus or minus the square root of 4, so plus or minus 2. Again, the negative isn't in my interval. Very large coincidence that I got the same answer. So I get x equals 2 for my derivative for both example 1 and example 2. Or, I'm sorry, not my derivative, my x value or my c value when my derivative equals the algebraic slope or the average rate of change.